Now we're, oops. All right, so what we're learning about today is trapezoid and kite stuff. I was supposed to ask you this question. What shape is that?
Trapezoid.
Trapezoid. You guys remember what the parallel sides are called?
Yes. Bases.
Base. Kind of have like a base 1 and a base 2. What are the not parallel sides called? Leg. Okay. This one's kind of like a perfect trapezoid. Normally, trapezoids can look like, well, kind of missed there, but they could look kind of weird like this. As long as they have a parallel, girls, as long as they have a parallel pair of bases, that's a trapezoid. If it's perfect like this, if these two are the same length, guess what kind of trapezoid that's called? Somebody in the other class actually guessed it.
Right?
No, that means it's a right angle. Isosceles. Why isosceles? Because isosceles means 2 equals, right? From triangle. So if the legs are both congruent, it's like a perfect trapezoid. It's called an isosceles. And if it is an isosceles, there's some stuff we know. Well, guess what we know about the diagonals? Okay, the diagonals are the same length. See how those are like matching exactly? Okay, also what we know is that these little parts right here are going to be like the same. See how those two look the same? My lines aren't perfect, but you guys, close enough, right? And then these two look the same. So the diagonals are congruent, but also like their little segments are congruent. These things. What else do we know? Actually, there we go. You guys know what I know about these two angles right here?
That 180.
Yeah, because the lines are parallel. Do you guys remember when we have parallel lines like that? What do I know about angles 1 and 2? They call them consecutive angles. If the lines are parallel, these add up to 180. So these add up to 180, these add up to 180. On an isosceles triangle, not only do these two add up to 180 and these two add up to 180, but the base angles are congruent. That means these two are the same and these two are the same. See how they look the same? A lot of times you might forget these rules, but if you look at the trapezoid and you say, man, those look identical, it is. Now, today we're saying we know it's true if it is an isosceles trapezoid. Or we could say it backwards. If these angles are congruent, then it has to be an isosceles trapezoid. Not one of these weird guys. Okay. Do these two angles have to add up to 180? No. Because these lines are not parallel. But these two do, and these two do. These two are the same, and these two are the same. Alright. I think that's everything we know about trapezoids. You got all that stored away in your brain somehow, magically? Probably not. Okay. Also, I have to draw this one. Kites. How's that? That's not bad. Okay, guess what I know about kite diagonals?
They make 90 degrees?
Yes, they are perpendicular every time, so that's one thing. This diagonal bisects the crossbar. That means this guy. See how these look identical over here, but these don't? Let's see, what else? Oh, I forgot one thing on trapezoids. I'll have to go back and get it. Okay. Also, this line right here, it bisects the angles. These two angles and these two angles. So, you can kind of tell like a bunch of little triangle, like side angle side. These little triangles are congruent. these little triangles are congruent, and these big triangles are congruent. So if the triangles look the same, they are the same. That's basically how it works on this. So like if I know this is 6 and this is 6, and if I know this is 30 degrees and this is 30 degrees and all that stuff. Yeah.
Wouldn't we also know that the crossbar bisects those angles?
No. If I drew it perfectly, you could probably tell, but
I get it.
I don't know. It doesn't work the same.
Yeah, I see now.
All right. Oh, the thing I forgot on trapezoids. Trapezoids. Oh, that's not what I wanted.
That's a very thin trapezoid.
Let me see if I can stretch them. Ooh, weird. It's ugly. Go away.
No, it's a very short trapezoid.
Okay. If I draw we had, on chapter 4, we had some of these things, the lines that are like drawn through the middle on triangles. Remember what we called them? We called them mid-segment. We didn't use that word very often. On a triangle, the mid-segment was like half of its base. On a trapezoid, you guys want to guess what we know about mid-segments on trapezoids?
They're parallel with the top and bottom.
Yeah, they're parallel with the bases. Also, the length, how do you think the length compares to the bases?
It's between the bottom one and the top.
Yes, it's halfway between this one and this one. In other words, it's the average of these two. So if this was like 12 and this was 18, how long would this be? You guys remember how to average two numbers together?
Add them together and divide by 2.
Yeah, 12 plus 18 divided by 2 is
Oh, that's right.
15. It's the number that's right in between the bases. See how it looks like a little longer in this one, a little shorter in that one, because it's right in the middle. That's how it works. You average the two. All right. Now we got it. Ready? Are you pumped? Are you excited for this opportunity? Okay. Number 1, we're finding the missing angles, angle B and angle D. So it says angle A is 110 degrees. How could I find, look at your book down. How could I find angle D? This is how you learn, you pay attention. Yep.
If that equals 1, and then they have that 180, so
Yes.
it's
These angles have to add up to 180. So you do 180 minus 110 is 70. Angle D is 70. Stretching our mental math here. 180 minus 110 is basically 80 minus 10 is 70 degrees. That's angle D. Okay, somebody else. Everybody's going to get one today. Angle B. How could we find angle B? Gracie.
You can either side do 180 minus 60 and then
Right, same thing. Angle B would have to be 180 minus 60, which is 120. She was correct. Okay, is number 1, is that an isosceles trapezoid? No, it's a little bit lopsided. And also the angles are not the same on the top and the bottom, so anyway, it's not. But number 3 is an isosceles trapezoid because it tells us AB and DC are the same length. So, somebody besides Will and Gracie. If A is 125, Emily, what would angle D have to be? 125, yes. On perfect trapezoids, isosceles trapezoids, those are the same. Okay, if D is 125, let's say A is 125. If A is 125, then how could we find angle B?
Subtracted by 180.
Yeah, 180 minus 125 will give us angle B. Those two angles have to add up to 180 because they're between parallel lines. So 180 minus 25, 125 is 55. So angle B is 55 degrees. So Jaden, if B is 55, then what's angle C? 55. Alright, that's all number 3. Number 5, find the length of the trapezoid, and it says find PR on number 5. Let's see, PR is that thing. So, PR is one of the diagonals. It says ST is 33. You guys see ST? Did I draw one of these earlier? Erase the diagonals. ST is 33, that's right there. And then it said PT is 20. Ooh. Alright. Well, if this is 20, guess what? I wish I would have drawn this better. Guess what that is?
TQ's
20. And if this is 33, this is 33. So anyway, the question was, how long was this diagonal?
the whole thing.
Yeah.
53.
53. Yeah, how long is PR? That would be 53. Any questions on that one?
53, right?
Yep. Number 7, MN. MN is a mid-segment. Remember what we said about the length of a mid-segment about 5 minutes ago? Great. Yeah, it's the average of the bases. So on number 7 it says MN is what we're trying to find. PS is 34, that's the left base. And 48, QR is 48, that's the other base. So basically MN is going to be the average of the bases. How do we average two numbers together?
And divide by how many?
34 plus 40, sorry, what was it? 8, whatever that is. 82 divided by 2, 41. Number 9. What shape is number 9?
Kite.
Kite. See all those triangles that look congruent to each other on 9? They are congruent to each other. It says find angle BAD. You guys see angle BAD in the picture? Yeah, somebody whispered the answer.
It wasn't me.
You don't whisper, you shout.
I didn't mention
No, I'm kidding. You just say it loudly. You don't whisper though. Alright. Yeah, if this is 35, then this is 35. So angle BAD, angle BAD would be this big angle right here. So how big has it got to be? Anybody? 70. That was the first question. Second question says angle BEA. You guys remember what we knew about diagonals in a kite? What does angle BEA look like? You guys see angle BEA in the picture? Yeah, it looks like 90. It is 90. In a kite, those always make 90-degree angles. So the second answer is 90 degrees, yes. Okay, now it says angle ABE. Angle ABE, right there. How could I find this angle right here? Well, it's the third angle in a triangle, Archer.
You can add the two angles together that you already know and subtract that by 180.
Yeah, 180 minus these two will give me that one, right? Three angles in a triangle. 180 minus 90 is 90, right? So really we just need to do 90 minus 35 to get that. What's 90 minus 35? Somebody say it. 55. Okay, now it's asking for angle ADC. That would be this guy right here. Any ideas how we could find him?
We know 55.
Let's see. Okay, we know this is 55. That's part of it. Okay, if this is 50, what's this?
50.
50. Yeah, I don't know what they call this line, but it's, I remember they called this one a crossbar. That's probably what you call it on a kite, like an actual kite. I don't know what they call this one, but it splits these angles in half perfectly. And what's this angle right here have to be?
90.
And then 50, 90 plus
140.
is 140. 180 minus 140 is 40. So to find this big angle down here, I can just do 55 plus 40. Which is 95. Okay, 11 might be a little bit easier. Hopefully, I don't know, maybe. Mari, number 11, what do you think angle A is? Yes, say it a little bit louder. Like authority, like you know what you're doing. Yeah, it is 47 degrees, she's right. Those angles on a and C are always going to be congruent on a kite. Are B and D going to be congruent? No. See how B and D don't look anything alike in the picture? That's because they're not. The picture's not to scale exactly, but in a kite those angles are not the same. How could we find the last angle? Carson?
180 minus 47.
No.
Wait, no.
Don't they all have to?
That's only on parallel lines. Does that trick work?
Oh,
They all have to
Yeah, what do the angles of a quadrilateral add up to?
360.
360. Do we have the other three angles? Yes, we do. We just said angle A was 47. So you do 360 minus 47 minus 47 minus 124, and that will give you the magic number. Yes.
What does a kite add up to?
All quadrilaterals add up to 360. Okay, number 13. All right, 13. Write triangle congruent statements for 3 pairs of congruent triangles in the kite. Somebody who hasn't answered yet, can you give me a pair of congruent triangles on number 13? Let's see, who hasn't answered? That would be Marianne, Tristan, Dylan.
XWV,
Okay,
ZWV,
say again, XWV and
WZV.
you gotta say them in the matching order. If you say XWV, what does that go with on the other triangle? Did you say XWV? Is that what you said the first time?
Yeah.
Okay, you gotta match the order.
Oh,
So like X on the top triangle matches what on the bottom triangle? Z. So it'd be Z what?
WB.
Yes. Is that what you said the first time? I thought it's like when I heard you it said like WVZ or something. Okay, I'm just deaf probably. Alright, that's one pair. Somebody else who hadn't helped. Gracie, you helped. Mason, you wanna try one? So Mason, you see triangle XVY
wait, what number?
on 13.
X, what?
You see triangle XVY in the picture?
Yeah.
What would that match on the bottom?
You said X, V, Y?
Yes.
Z, V, Y?
Yes. So that'll be our second one. X, V, Y, Z, V, Y. Okay, and Jasmine, you try the big one. Okay, on top, Jasmine. Oh, you don't. Okay, the top triangle is WXY, right? What does that match the big triangle on top? What does that match on the bottom?
WZY.
Yeah. So, did I say WXY? WXY and WZY. Alright, that's it for that one. Alright, 15 is a little bit tricksy. Do you guys see that like ACEG is a trapezoid? ACEG in the picture is a trapezoid. And, but like BDF is a triangle or CDF is a triangle. So you kind of got trapezoids and triangles going on here. Okay. 15 says find BF and AG if CE is 8. I probably should draw a picture. I don't know if I can.
Maybe 24.
No. Oh, actually it would, but how'd you get that? Did you say AG?
Yeah. Okay. Dinner. So you drink one and then you.
Okay, I failed. I think you got lucky. So, the way you have to start this one is by looking at the triangle. This is, they tell us like these are equal and these are equal. So, this is a mid-segment for this triangle right here. So, if this is 8, how long is this? How does a mid-segment relate to its base? It's 16. Okay, on a triangle, the mid-segment is going to be half as long as its. If you think about it, it makes sense. Like this is 0, this is 16, this is going to be right in the middle of 0. Anyway, never mind. Now to get we also need this guy right here. I can't remember what the letters were, but AG. So we're going to have to use our trapezoid for that. This black thing is a trapezoid. 16 is the mid-segment in this trapezoid. And what do we know about mid-segments in the trapezoid? They're lengths. They're the average of the bases. So if I call this base X, how could I set that up?
16 times 2 minus 8 equals X.
Let's do it algebraically.
X plus 8
There you go.
divided by 2 equals 16.
Yes.
So multiply by 2
Yeah. If you average X and 8, it should come out to 16. How do we solve this with algebra? This whole size divided by 2? times 2 first. So x plus 8 equals 32 minus 8. So yeah, 16 and 24, that'd be the two answers. So 24 is triple that.
Are you gonna have a sort of thing on today?
Oh,
Find the extent
probably not that
ratio
particular
of
problem, but
C.
something like
Because
that.
if you,
They're all, okay, what you can, I haven't made the test or looked at it yet, but what you can pretty much guarantee is there will be a trapezoid midpoint or mid-segment thing.
couldn't you just add 16 plus 8?
You could have, but we didn't know that at the beginning.
Well, I mean, you can also.
You were just making stuff
You
up
just
there.
count it by 2 and then times it by 3.
Yeah, it's more like times 2 and times 3. That's really kind of how it works.
What about the find the extended ratio?
Yeah, the extended ratio, I was going to skip that part, but it would be 1 to 2 to 3.
So
It's,
now we put
it's
that-
8 to 16 to 24, which reduces to 1 to 2 to 3. Yeah, I was going to skip that. Anyway, okay. Didn't think anybody would notice. 19. Let's go to Kite.
Not everything. Just able to distinguish whether it's the male name or someone else.
Okay, Aiden, what do I know about angle B and angle D in that picture? Yes. So they have to be the same. If you look at the heading on the problem, it says B plus D equals 235. So if they're both the same angle and they add up to 235, how do I find each of them? Divide by 2. Anybody do that, divide by 2 in their head? Too late, you already put it in the calculator.
No, I didn't see it. 107?
Now,
Wait, no.
I know it, but I just. Well,
anyways,
he.
117.5?
yeah, that's it. 117.5.
With the calculator.
No, I looked away before I got the answer.
Okay, anyway, A is 90, because they tell us that. We're supposed to find all the angles. That's the B and D are 117.5. So right, 117.5, 117.5. And then, who hasn't answered one? Dylan, wait, did you answer one? I think everybody answered one.
Yeah.
All right, I guess so. Anybody can. How could I find angle C? Gracie, they have to add up to 360.
360 minus 90 minus 11.
Yeah, 360 minus those three things we already have.
There you go.
You could just do 360 minus 90 minus 235. That'd probably be easier, right?
Yeah. Why would you want to do that?
35, is that what you guys got?
Yes.
8?
8.
18? Well, you know B and D have to be the same thing, right? So just set those equal to each other and solve for x. And that's pretty much, once you get x, you plug it back in.